Good morning, children. It's me, Kavya, your maths teacher. Last class, we started with number system chapter. There, we learned what are natural numbers, what are whole numbers, and also what are rational numbers. Hope you all remember it. What are rational numbers? Any numbers which can be written in the form of p by q and q not equal to 0 are called rational numbers. And we also studied few examples of it. In today's class, I am solving the first exercise of this lesson, that is exercise 1.1. And this time I have worked out the problems in the book and made a video of it. I have solved the whole exercise and I want you all to maintain one separate classwork for arithmetic and work it out in your classworks. Any doubts you can clarify with me. So, here is your exercise 1.1. The first question is 0 a rational number? Hope it is clear to you. Is 0 a rational number? Can you write it in the form of p by q, where p and q are integers and q not equal to 0 is the question. Hope the question is clear to you. Here is the solution for it. First part of the question was, is 0 a rational number? The answer is yes. 0 is a rational number. Why? Because 0 can be expressed in the form of p by q, where q, that is denominator q, is not equal to 0. Hence it is a rational number. Second part of question was, can you express it in the form of p by q? Yes. So examples you can see. Here we are proving that 0 is a rational number. Hence in all the examples you can see in the numerator we have 0. In the denominator, you can write any number with positive or negative signs, but it should not be 0. Why? What if it becomes 0? I explained that to you in the last class. 0 by 0, which is undefined. Hence, the denominator q should not be equal to 0 according to the definition of the rational number. So, 0 by 1, 0 by 3, 0 by 4, 0 by minus 16, 0 by minus 8, etc. Anything you can write. Numerator is 0 and denominator can be any number except 0. Hence the answer is 0 is a rational number and it can also be expressed in the form of p by q. Now look at the second question of the exercise. Find 6 rational numbers between 3 and 4. So in between 3 and 4, how many 6 rational numbers we need to find out? As we all know, there are infinite number of rational numbers between 3 and 4. But they are asking us to find out only 6 rational numbers between 3 and 4. For that, what we should do is, they have asked to find out 6 rational numbers. So how many number of rational numbers they have asked, always consider that number. Here it is 6. So take that number 6 and add plus 1. Suppose if they are given 4, then write 4 plus 1, that is 5. If they have asked to find out 3 rational numbers, then it is 3 plus 1, that is equal to 4. Like this, how many number of rational numbers you need to find out, you should check and add plus 1 to that. Here they have asked us to find out 6 rational numbers between 3 and 4. So what we do is do 6 plus 1, which is 7. After finding out this number, next what you need to do is multiply and divide that number by this first number, that is between 3 and 4 they have given to you. So consider the first number given 3. So 3, you consider 3 into 7 divided by 7. 3 into 7 divided by 7. Now multiply. 3 7s are 21 divided by 7. In between 3 and 4. So we took 3 and multiplied and divided by 7. Now consider the next number, that is 4. Between 3 and 4. So again consider 4. Multiply and divide by 7. 4 7s are 28 divided by 7. So we need to find out the fractions in between 21 divided by 7 and 28 by 7. So first number what we have got for 3 is 21 by 7. Leave that number. After 21, we are changing only numerator. Denominator we are keeping constant. What after 21? It is 22. 22 divided by 7. Next, 23 divided by 7. Next, 24 by 7. 25 by 7. 26 by 7. 27 by 7. Next is what? 28 by 7, which is you are getting equal to 4. How? See, 7 1s are 7 4s are. 7 4s are 28. So we cannot write 28 by 7 4. Here also 7 1s are 7 3s are, which is again equal to 3. Hence you cannot write that in the beginning. Why? They have asked to find out the rational numbers between 3 and 4 and not 3 and 4. So after 3, whatever we get, and before 4 what we get, those numbers we need to mention. So we find out that 3 can be expressed as 25 by 7, which is equal to 3. 4 can be expressed as 28 by 7, which is again 4. So in between 21 by what after 21 by 7, what before 28 by 7 we need to find out and write. Simple. You got 21. So 22, 23, 24, 25, 26, 27. You cannot write 27. Why? If you write 27, again it will be equal to 4. And the denominator remains the same number 7. So 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7 and 27 by 7 are the 6 rational numbers between 3 and 4. If you want, you can count 1, 2, 3, 4, 5, 6 numbers are there. So this is the solution. To make you understand better, I have considered one more example. The question is, find 5 rational numbers between 1 and 2. So we need to find how many rational numbers? 5 rational numbers. Between which 2 numbers? Between 1 and 2. Now the first step is how many number of rational numbers we need to find out, you need to check. So it is clear that it is 5. What is the first step? Consider that number. Add 1 to it. 5 plus 1 is 6. We got 6. What we have to do with this number now? Consider the first number 1. Multiply and divide it by whatever the number we got. So it is very clear. 1 6 6 divided by 6. When you simplify, you get 1 again. 6 1s are 6 1s is 1. So 6 by 6. Next is between 1 and 2. So next number is 2. Consider 2. Multiply and divide it by 6 again. 2 6 12 by 6. So when you simplify, 6 1s are 6 2s are. It is again 2. So if you write the fractions, apart from 6 by 6 and 12 by 6, you get 5 rational numbers between 1 and 2. I cannot choose 6 by 6. So I will go with next number, that is 7 by 6. I am telling you again, the denominator you should not change. Only go on increasing the numerator values by plus 1. So 7 by 6. 7 plus 1 is 8 by 6. 8 plus 1 is 9 by 6. 9 plus 1 is 10 by 6. 10 plus 1 is 11 by 6. I cannot write 12 by 6. Why? What will happen if I write 12 by 6? 12 by 6 is 6 1s are 6 2s are, which is again equal to 2. I want the rational number between 1 and 2 and not equal to 1 and 2. So I will stop at this 11 by 6. How many numbers did we find? 1, 2, 3, 4, 5. Hence we have found out 5 rational numbers between 1 and 2. Hope you are clear, children. Next you have third question. Find 5 rational numbers between 3 by 5 and 4 by 5. Till now we studied 2 examples with whole numbers. Now you have fraction, that is 3 by 5 and 4 by 5. Here you have the solution. To find 5 rational numbers between 3 by 5 and 4 by 5. Now what is the first step? How many number of rational numbers you need to find out? You should check and add +1 to that. Here it is 5 rational numbers. So 5 plus 1, which is equal to 6. Whatever number we get on adding, that you should multiply and divide by 3 by 5 and 4 by 5. So let us consider the first fraction, 3 by 5. Multiply and divide this by 6. What do you get? 3 into 6 is 18 divided by 5 6 are 30. We got 18 by 30. Similarly, consider the next number, 4 by 5. Again, you will need to multiply and divide this by 6. 4 6 24 divided by 5 6 are 30. So we got 18 by 30, 24 by 30. Try simplifying this. 18 by 30. 6 5s are 30, 6 3s are, right? I will show you here. 18 by 30 we got. 6 3s are 18, 6 5s are 30. We got again 3 by 5. Correct? Which is the first term here. Similarly, 24 divided by 30. 6 4s are 24, 6 5s are 30, which is 4 by 5, which is the required second number. So, in between this 18 by 30 and 24 by 30, we need to find out 5 rational numbers. It is very simple, as you all learned now. Denominator does not change. 30 is fixed. Numerator, you should go on adding +1. So, first term we got is 18 by 30. 18 plus 1. 18 plus 1 by 30 is equal to 19 by 30. Again 19 plus, this is first term, 19 plus 1 by 30, that is 20 divided by 30. Next 20 plus 1 divided by 30, that is 21 by 30 is the third term. We need to find 5 rational numbers. So we are not yet done. We have only found out 3 terms. So next is, we got here 21 by 30. Next continue. 21 plus 1 divided by 30, that is 22 by 30. 22 plus 1 divided by 30, that is 23 by 30. I cannot write next number 24 by 30. I should wind up here. Why? 24 by 30 if I do, I get 4 by 5, which is the given number here. So we have found out 5 terms. Which are they? 19 by 30, 20 by 30, 21 by 30, 22 by 30 and 23 by 30. 1, 2, 3, 4 and 5. Hence we find it out 5 rational numbers between 3 by 5 and 4 by 5. Hence the solution. Hope you are clear, children. The last main of this exercise is say true or false. That is, state whether the following statements are true or false and also give reason for your answers. So they are asking the reasons as well. So first question is, every natural number is a whole number. What do you think? Is it true or false? False? So the solution for this is true. What are natural numbers? We have studied it in last class. 1, 2, 3, 4, etc. are natural numbers. Whole numbers are all the natural numbers including 0 are called whole numbers. Hence we can say that every natural number is a whole number. But every whole number is not a natural number. Keep that in mind. Second question is, every integer is a whole number. State whether it is true or false and also give the reason for this. So to answer all these children, you should know the definitions, mainly what are natural numbers, whole numbers, or what are rational numbers. Okay. So the question is, every integer is a whole number. The answer is false. Why? Integers means 0, all the positive numbers and negative numbers together. You all know to represent the numbers on a number line. You have studied. So 0, plus 1, plus 2, plus 3, plus 4 on one side, minus 1, minus 2, minus 3, etc. on other side. This is how you represent the integers. So the numbers with positive signs and negative numbers along with 0 are integers, whereas whole numbers are 0, 1, 2, 3, etc. Now every integer is a whole number is the statement stated by them. So 0, 1, 2, 3, the natural numbers along with 0 are called whole numbers, which you have studied. But the condition is those whole numbers are numbers without fractions and decimals. Numbers without fractions and decimals means the statement made here that every integer is a whole number is false. Why? Because whole number does not include these fractions and decimals. In the third question, every rational number is a whole number is the question. So you know what are rational numbers. We studied that in last class. The rational numbers are numbers which can be represented in the form of P by Q and Q not equal to 0. Numbers like 0, 1 by 2, 3 by 4, minus 12 by 7, etc. are called rational numbers. Numbers 0, 1, 2, 3, etc. up to infinity, which are without decimals and fractions, are called whole numbers. So now you itself think that whether every irrational number can be a whole number? No. Every rational number cannot be a whole number. Why? Whole numbers does not contain decimals or fractions. Hence the answer is false for the third question. So this is about exercise 1.1, children. Hope the solutions are clear to you. If you have any doubts, please feel free to text in the WhatsApp group. So after studying about rational numbers, today we shall just get an idea about what are irrational numbers. The next topic in your textbook is irrational numbers. So we studied that any irrational number is a number which can be expressed in the form of P by Q, where Q not equal to 0. So this the opposite statement of that is the definition of your irrational number. That is, you can see the definition in your textbook there. A number S is called irrational if it cannot be written in the form of P by Q, where P and Q are integers and Q not equal to 0. So, a number, if it cannot be represented or written in the form of P by Q, where P and Q are integers and Q not equal to 0, then we call such numbers as irrational numbers. If at all we can represent or we are able to represent it in the form of P by Q, means it is called rational numbers. If it cannot be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0, are irrational numbers. So, what are the examples for these irrational numbers now? So the examples you can see here are square root 2, square root 3, pi, which is equal to 3.14, and one more example decimal number you can see here. It is 0.101, and it goes on. It is not ending, means it is not terminating. Terminating means which ends. This is not ending. The dots which are represents here are it is continuing. If you observe, you have studied this in your lower class. 101, 101, 101, 101, like this you have, means it is recurring. So, such decimals are also example for these irrational numbers. So, what are irrational numbers? Any number which cannot be expressed in the form of p by q and q not equal to 0 are called irrational numbers. Examples can be square root of any number 2, 3, 4, 5, etc. Pi, which is a constant and equal to 3.14, which is a decimal number. And one more decimal example what you learned today is 0.101, which is recurring and non-terminating. It is not ending, it is continuously. You will get it as 101, 101, 101, like that. All these can be examples of irrational number. So pi is equal to 3.14 is an irrational number, agree. But why such recurring form is an irrational number? How? The answer to this we shall discuss in next class. Till then, solve that exercise 1.1 completely. Any doubt, please drop a message in the WhatsApp group. Thank you, children. Have a nice day.